Hello, 8th grade science and students, and welcome to our presentation on measurements. Make sure you get out a pencil, your Cornell notes, and remember to watch the video once through and then take your notes. Measuring matters. A unit is used to describe how much of something there is. So when we measure, we look for units to know how much something there is. Sometimes you're measuring liquids, sometimes you're measuring rocks, sometimes you're measuring squares. They're all different shapes, and it's really important to know how much of something there is so you can measure it. When we measure, we have an English system, which we know has length, volume, and mass. We measure length, and below on the bottom you can see right here, length in inches, feet, or foot and miles. A metric system in meters, liters, and grams. And we know them as like kilometers, centimeters, millimeters. So for the metric system, centimeters would be starting out with the centi, and then the meters in length, grams, liters, things like that. Here is a chart that we might be going over later. It's so you start at the base here that has meters, liters, and grams. This is the metric system. If you go up by 10, it's a decaliter, or decameter, or decagram, hectometer, hectoliter, hectogram, kilo. We go down to deci, centi, and milli. Milli is the smallest measurement. Centi is the largest measurement in the metric system. Objects have mass and volume. Today we're going to be talking about mass and volume. Mass is the measurement of the amount of matter an object contains. What's mass? The measurement of the amount of mass of matter an object contains. Mass is the measurement of the amount of matter an object contains. Different objects contain different amounts of matter, so they have different masses. I put down here a scale of mass and weight because sometimes that gets confusing. Mass never changes. It can be seen in grams, kilograms, things like that. It's part of density. It's measured with the balance, and we'll talk about that in a little bit. It measures the amount of material in an object. So mass measures the amount of material or matter an object contains. It's a physical property of matter. Weight also measures matter. They both measure matter. Weight changes due to gravity. It can be measured in newtons, and it's measured with the scale. So that's how they're different. Pause to take notes. Which dwelling has more mass? Is it an elephant or a mouse here on this picture here? Which one? Mass is talking about in the metric system, and weight is different. Which one is more massive? Which one is larger? The elephant, you can see it's more massive, it's more larger. Yes, it does weigh more, but we're talking about mass, not weight. And then these basketball, soccer ball, and the baseballs, they have different masses. They are more massive than the other one. They take up more space. Just like this little boy, and he's trying to push on the big truck. Truck has more mass than this little boy here. Of mass. Mass is often measured in metric units, and we talked about metric units before. Metric units of mass are kilograms, grams, and millimeters right here. Measuring mass. We use tools such as this triple beam balance to measure mass. We use it to find the mass of the object, how massive it weighs. There's the pan right here that shows where you could put the object. Here's the movable masses, and then the balance mark, where it balances out on the scale. Objects have mass and volume. Now we're going to talk about volume. Volume is the measurement of the amount of space an object takes up. So here we have two different shapes. And this one has more volume because there's more objects in it that take up the space. Volume is how much space is often taken up by an object. Just like if you had a cup of water, it has volume in. The volume is the water. Which of the following has more volume? An elephant or a mouse? Which one has more volume? Remember, volume is the amount of space an object takes up. Neither. They have the same volume. They both fill up the same space. This mouse has not as massive space, but it still takes up its whole space. The elephant is a more massive object, but it still takes up the same volume. They're not different volumes. Measurement of volume. Volume is again often measured in the metric units, liters, milliliters, and this is centimeters cubed. Here's an example of a liter, 1 liter of soda on the right side. See the liter right here. Measuring volume of regular objects. So we're going to talk about regular objects. How do you measure volume in irregular objects? Just like I said, if you had a cup of water, it's easy to measure that because it's in a glass. You can measure cylinders and things like that. If it was an irregular object such as a rock, that's really hard to measure. You can't use a ruler. You can't use, it's not a very square shape or rectangular shape. It's hard to measure. So we're going to look how to find the volume of a regular object, a rectangular solid object. For this one right here, we have, you measure the length, width, and height. The equation is volume equals 1 times width times height. So for solving for the volume of this rectangular solid here, we would multiply the length right here times the width, how wide it is, times the height. Pause to take notes. Let's try how we would solve the volume. If you had a pizza box with the length of 40 centimeters and the width of 40 centimeters and the height, do you see the height here is a lot smaller? It's only 8 centimeters. Find the volume of the pizza box. So how much pizza could this box hold is what it's asking. What could the volume of this pizza box be? So our equation is volume equals length times width times height. So our length is 40. So we would plug in 40 here times 40 for the width times the height of 8 centimeters. The volume equals 12,800 centimeters cubed. Now try it on your paper. So I want you to write down the equation. Volume equals length times width times height. And then you're going to plug in the 40 centimeters length, the 40 centimeters width, and the 8 centimeters height. So try it on your paper, okay? Pause to take notes. Pause to take your notes and also write that equation down on your paper. Go back and look at the equation and it's all written out for you. But displacement, you have to measure the, you put some water in a container and you measure it's 10 centimeters cubed. You put the object in and then the displacement, the area where the object is, gets raised because the regular object takes up the space and it raises up to 15 centimeters cubed. So there's 3 steps to measure volume. Just like that picture, you add water to a graduated cylinder, which is a long, tall, skinny cylinder, and record the initial volume. So what volume it initially started out with. Then you're going to put the object in the water and record the new final volume of the water with the object in it. So this process is called, you're finding how to measure a regular object with a process called displacement. Then lastly, you're going to subtract the final volume minus the initial volume, and that equals the difference in volume of the object. To find the volume of a regular object, you need to subtract the final volume. So you would have the final volume minus the initial volume, and that equals the difference in the volume of the object. So here's an example. The water in this graduated cylinder is at 20, and they put in their irregular object, which looks like a rock. And it looks like the volume of the object ends about 23. So you would subtract 23 minus 20 to find the volume of the object, which would be 3. 3. Another example, it's kind of hard to read, but this says, how much volume does this object have? So the first thing you would do is you'd measure your initial volume. You put the object into the graduated cylinder to find out. Since the water in this one weighs 2 units, the object has a volume of 2. So you would take the initial recording of the volume, then you put the object in, record the final unit of measurement here, and then you subtract. Difference in volume. Measuring regular object volume uses that equation, volume equals length times width times height. Measuring irregular objects, you use displacement with those 3 steps. And here is a measurement conversion table. We'll talk a little bit more about that in class. On the left-hand side, here we have US conversions to metric systems.